Hello to all the students. So in this video we are going to discuss about the last topic of probability, that is normal distribution. A random variable x is said to have a normal distribution with parameters mu, that is mean, and sigma square, which is variance, if its density function is given by the probability law. Okay, so in this, a random variable x is said to have a normal distribution if it has got the mean as well as the variance. Next, normal distribution is another limiting form of the binomial distribution after Poisson's distribution, and it has also got the same two condition as that of the Poisson's distribution. Means over here n, which is the number of trials, are indefinitely large, means it is almost equals to infinity, and neither p nor q is very small over here. The normal probability curve with mean mu and standard deviation sigma has the following property. Okay, so first one, it is a perfectly symmetrical bell-shaped curve. Okay, like this, or you can say Gaussian curve. Okay, now over here, the very important thing that you should know is this this line, it never joins this line. Okay, there is always a difference. Okay, there is always a difference. This line never touches the x-axis. This thing you should always remember. Next, the theoretical normal distribution is a continuous probability distribution and consists of an infinite number of minus infinity to plus infinity. Okay, so this x-axis, it starts from minus infinity and ends up to plus infinity. Fine. Next, at the center there is mean, which is equals to median, which is equals to mode, and it is represented by mu. Okay, mean is equals to median is equals to mode. It is given by mu, and what is mu? We know mu is mean. Okay, so at the center we have got mean, which is denoted by the symbol mu. Next thing, the total area of the normal curve is 1. Okay, so starting from minus infinity to plus infinity, the total area is equals to 1, and the central value divides the whole area into two equal parts. That is, the area from minus infinity to mu is 0.5 and mu to plus infinity is 0.5. So 0.5 plus 0.5 is equals to 1. Okay, so minus infinity to plus infinity, the entire area is equals to 1. Okay, and the mu, the central line, it will divide it into two equal halves, that is 0.5 and 0.5. This thing you should remember. Next, normal distribution is given by the equation z is equals to x minus mu divided by sigma. Now what is z over here? Z is value which represents area. Okay, but Z is not an area, it just represents an area. Means with the help of Z we can calculate the area. Now with area I mean probability. So in this normal distribution curve, or you can say Gaussian distribution curve, we always say for probability we always say area. Okay, so whenever I'm saying area, or in question also, or during solving the problems also, I'll be saying area, but here with area I mean probability. Okay, next, x is equals to required value to be found. Okay, that has to be found. Mu is mean and sigma is standard deviation. These all things you know. So we'll take up an example and you will get to know how to use this normal probability distribution for solving the problem, like for calculation of probability. Fine. So the problem goes like this. Tablets patches of 100 mg tablet. Limits are, first of all, not more than 2 of 20 tablets may differ from the average weight by more than 10%. Second limit is no tablet may differ from the average weight by more than 20%. Next, we have got the batches. N is 30 lakhs, mean is 101.2 mg, standard deviation is 3.92 mg, and probability area for 0 to 2.58 is equals to 0.495, and p area for 0 to 5.16 is equals to 0.5006. Okay, so this is our problem question. Now, first of all, we need to understand this question, then only we'll get to know. Okay. So, what we are doing over here, some tablets are being manufactured. Okay. And what is the weight of the tablet? Each tablet is weighing 100 mg. Fine. But over here, mean is also given. Okay. Mean value you can see mu. Mu is how much? Mu is 101.2. Okay. So, mean is here. You can see 101.2. What does it mean? See, we are making 100 mg tablet. Okay, each tablet should weigh 100 mg. This is our goal. But some plus or minus thing will occur. So we are taking a mean. We are considering a mean of this much, 101.2 mg. Fine. Now, limitation number 1 is not more than 2 of the 20 tablets may differ from the average weight by more than 10%. Okay, like we are making some tablets and we are picking up 20 tablets. So among those 20 tablets, not more than 2 tablets should differ in average weight by more than 10%. Means the 2 tablets, they may not be the average, the mean weight 101.2 mg. They may not be 101.2 mg. Okay, there may be plus or minus weight, but that plus or minus should not be more than 10%. Okay, means the weight should not be more than 10% or less than 10%. How much? Not more than 20 tablets. Okay, so in a batch we are picking up 20 tablets, and among those 20 tablets, not more than 2 tablets should be 10% more weight or 10% lesser weight. Okay, now second limitation is no tablet may differ from the average weight by more than 20%. Okay, so whatever tablets has been manufactured, not even a single tablet may differ by more than 20%. Okay, not more than 20% or less than 20%. Okay, it should be within 20%. All the tablets manufactured, the weight should be within 20% of the mean weight. Okay, I hope you people understood. Now we'll check out the solution. Now over here, the first limitation was not more than 2 of the 20 tablets may differ from the average weight by more than 10%. Okay. Now over here, not more than 2 of 20 tablets. That means not more than 10 of 100, that is more than 10%. Okay, so whatever number of tablets are being prepared, not more than 10% should differ by 10% of weight. Okay, 2 of 20 tablets is, it also means 10%, isn't it? 20 divided by 2 will get 10. Okay, isn't it? So it should not differ by 10%. Next, mean value is 101.2 mg. Okay, now mean 10% of the mean means 10.12 mg, isn't it? 10% of the mean is 10.12 mg. Thus, limit is 101.2 mg plus or minus 10.12 mg. So, the limit should be 91.0108 to 111.32. So, what are these values? When the mean value, the mean weight over here is this much, 101.2. Okay, so it should not differ by 10%. So 10%, we took 10% of the mean value and we got this value, 10.12. Okay, so differ by 10 means plus 10 or minus 10. So what we did, 101.2 plus 10.12, we got 111.32. Similarly, what we did, 101.2 minus 10.12, we got 91.08. Okay, so this is the difference. Okay, so 10% of the tablet should be within this much of limit. So we need to calculate that among them what is the probability that it should be within 10%. Okay, 10% of the tablets are within this much. Matlab, less than 10% of the tablet should have this much of no weight, that you need to estimate. So not more than 10% tablets should have weight less than 91.08 mg and more than 111.32 mg, and 90% of the tablet should be within the limit. Okay, 90% of the tablet should have weight more than 91 and less than 111. Just 10% of the tablet have got the freedom that their weight can be less than 91 or more than 111. Okay, I hope you people understood this thing with the help of these two sentences. Okay, so not more than 10% of the tablet should have weight less than 91 and more than 111. Okay, not more than 10% means less than 10% of the tablets can be have the weight less than 91 and more than 111, but not more than 10% should have such values. And next thing is 90% of the tablets should have the limit, means their weight should be more than 91 and less than 111. Okay, next we'll solve for this thing. So not more than 10% of the tablets should have weight less than 91 and more than 111. So we can solve it in two parts, like how many tablets can have weight less than 91 and how many tablets can have weight more than 111. So part 1 is tablets having weight less than 91.08 mg. This will calculate. Okay. So we can make this graph, and mu, the mean value is 101.2. Fine. Now what is the weight? The x value over here, it is 91.08. So 91.08, whether it is less than mean or more than mean? Yes, our mean is 101. So 91 is less than mean, isn't it? So it will come at the left hand side. Okay, right hand side means more than mean, left hand side means less than mean. Okay, now what you can see, the tablets weights are, yes, it is less than 91. So less than 91 means it will go to more left hand side. Okay, so this blue shaded area, what you can see, this thing, this is the probability of the tablet, this is the area of the tablet that is less than 91.08 mg. Okay, now we'll write this formula, z equals to x minus mu divided by sigma, and we know all the values. X value, that is required value, is 91.08 minus mean is 101.2 divided by sigma is 3.92. So calculate it, we got the z value as minus 2.58. So this is the z value. Okay, this dotted line, this is the z value, and the z value at the mean is always is equals to 0. Okay, so this mean value is there. Here the value of z is 0, and at this dotted line here the value of z is minus 2.58. Okay, so minus, with minus we mean that it is to a negative side. If it is plus 2.58 means it will come to right hand side of the mean. Okay, so minus plus, this thing we know, we need not to do over here. Minus means it reflects, it denotes that the value comes at the left hand side. The area should be considered to be at left hand side of the mean. Now it is given here in the question itself. The value of P, probability of the area 0 to 2.58 is 0.495. Okay, so the area between 0, so this is z equals to 0 at this point and z equals to 2.5 at this side. So this entire area is to be 0.495. Okay, this area is 0.495. And what is the value of this entire area from mu up to infinity, yes, this value is, we know the entire value is 0.5, isn't it? So what we want to calculate? We want to calculate this shaded area, isn't it? So how can we calculate? We'll just subtract 0.95 minus 0.495. So you get the value of that blue shaded area. Blue shaded area means it is the area for less than 91.08. So you got the value 0.005, that is 0.5%. So you can say probability of the tablets to be weighed less than 91.08 mg is 0.005 or 0 or simply 0.5%. Okay. So what was our requirement? It not more than 10% should weight so and so, but here the value is just 0.5%. Okay. So among those batch of tablets, just 0.5% tablets have got the probability to be weight less than 91.08 mg. Okay, so this was first part. Similarly, we'll calculate for part 2. Part 2 means the tablets that have got weight more than 111.32 mg. Again, we'll make this bell-shaped curve. So, mu is 101.2 mg. Now, what is the weight we are expecting? That is 111.32. So 111.32, whether it is less than mean or more than mean? Yes, it is more than mean. So we need to make a line, like that only, anywhere in the right hand side. Okay, approximately you should make at the right hand side. Why right hand side? Because the value is more than the mean value. Okay. Now, what is the weight of the tablet? Whether it is less than or more than? Yes, it is more than. So, it should be more towards the right hand side. So, you need to calculate the area of this blue shaded part. Okay. So, this blue shaded part says the area which is more than 111.32. Okay. Now, we'll calculate the value of Z by keeping all the values. Over here, X is 111.32 minus mu and sigma, we know the values, just go on calculating it. We got the value 2.58. So over here 2.58, and at the center the value of Z is always 0. Okay, so this center part, this line is 0, and this dotted line, the value of Z is 2.58. And now what is given in the question itself? Yes, the value of P, the area from 0 to 2.58 is 0.495. Okay, so the areas from here ending up to here. Okay, so 0, this line shows 0, and this dotted line shows the value of Z, which is 0.258. The entire area is 0.495. Okay, now this entire area is, yes, 0.5, and what we need to calculate? The area of this blue shaded part, isn't it? So we can write 0.5 minus 0.495. You got the value 0.005, that is 0.5%. Thus, the probability of tablets to be weighing more than 111.32 mg is 0.005 or simply 0.5%. Now, probability of the tablet to weigh below 91.08 mg is 0.5%, and to weigh more than 111.32 mg is 0.5. Okay, so thus this thing, not more than 10% of the tablet should have weight less than 91 mg or more than 111 mg. What you can say? The probability that the tablet will weigh less than 91 or more than 111 mg is 0.005 plus 0.005, that is 0.01, or you can say simply 1%. So what was our requirement? Yes, what was our limit? Can you see in this question itself, the limit number 1 you can see over here, not more than 10 of the 20 tablets. So 10 of the 20 tablets means 10%. Okay, 10% may differ the average weight by more than 10%. Okay, so more than 10% means the limit was 91 to 111. But what we got? We got acceptable value, just 1%. There is only probability of 1% of the tablet to differ in the weight from the average value by more than 10%. Okay. So only 1% of the tablet have got weight less than 91 and more than 111 mg. Okay. Now this problem, first part has been solved. Okay. Now we'll go to the second part of the problem, that is no tablet may differ from the average weight by more than 20%. Okay. So whatever batch of the tablet we have produced, not even a single tablet may differ by 20%. Means from average weight it should not be less than 20% or more than 20%. It should be within the limit, within 20%. That is our requirement. Now mean value is 101.2. Okay, and 20% of the mean value is 20.24 mg. So how we are calculating it means, see, 100% of the mean, you know how much it is. Just you take this decimal point over here and it will be 10.12. 10% of 101.2 is 10.12. So 10.12 plus 10.12 will be 20.24. Very simple. Okay. Next, thus limit is 101.2 plus or minus 20.24. So the limit is 80.96 to 121.44. So what we are doing, 101.2 minus 20.24 will get 80.96 and 101.2 plus 20.24 will get 121.44. So this is the limit. So all the tablets should be within this limit. No tablet should go beyond this limit. This is our requirement. This is our limit that we need to check. So no tablets should have weight less than 80.96 mg and more than 121.44 mg. This is our requirement. Okay. So we'll check out. So we'll have again two parts. Like we'll check out that whether the tablets are weighing less than 80 mg, and second part whether the tablets are weighing more than 121 mg. Okay. So tablets weighing less than 80.96 mg. Again we'll make this normal Gaussian curve. New value is 101.2. Okay. Now what is the weight over here? X value is 80.96. So 80.96, whether this value is less than mean or more than mean? Yes, it is less than mean. So you need to make a line at the left hand side approximately. Okay, so this is X value 80.96. And the tablets, what we expect, less than 80 or more than 80? Yes, it is less than 80. So it is more towards the left hand side. So we need to make a shading or an area we need to select which is more to the left hand side. Next we will calculate the Z value. Okay, X is 80.96 minus mu and sigma value to you people know. So you got the value as minus 5.16. So minus means it is something which is at the left hand side. Okay, now can you see in this question over here the value of P area 0 to 5.16 is 0.5006. Okay, so this is Z, the value of Z is minus 0.156 and value of Z at the center is 0. So the value between over here, that is from the mean value up to this dotted line value, this entire area value is 0.5006. But what area we require? We require this area, that is less than 80.96. So this entire area is 0.5 we know. So 0.5 minus 0.5006, we got the value 0.0006, or you can say approximately 0%. Okay, thus the probability of the tablets to be below 80.96 mg is 0%. Okay, now similarly we'll calculate this for part 2. Tablets that are weighing more than 121.44 mg. Again we'll make a normal distribution curve. Mu value is 101.2. Okay, now the weight of the tablet is 121.44 mg. So whether this weight is less than mean or more than mean? Yes, it is more than mean. So you should need to make a line at the right hand side because it is more than mean. Now the weight of the tablet is, what you can see, more than 121.44 mg. So you need to select an area which is more towards the right hand side. Okay, now calculate the value of z. I believe you know everything from now. So you got the value as 5.16. So this dotted line, the value is 5.16, and at the center the value is 0. Now again in the question itself it is given the value of area from 0 to 5.16 is 0.5006. Okay, so starting from this point 0 to 5.16, okay, the area is 0.5006, and this entire area is 0.5. So simply you need to calculate the blue shaded line, isn't it? The extreme right side area you need to calculate. So 0.5 minus 0.5006, you got the value 0.0006, which is approximately 0%. So thus the probability of tablets to be more than 121.44 mg is 0%. So you can write probability of the tablets to weigh less than 80.96 mg is 0. Probability of the tablets to weigh more than 121.44 mg is also 0. Thus, the probability of the tablet to weigh less than 80 or more than 121 is also 0. Okay. So, this was our way to solve the thing. And this was all about our today's video regarding normal distribution. Okay. I hope you people found this video helpful. Thank you for watching.